Hello friends, welcome to my YouTube channel. I hope you all have been following and watching my videos recently. So are you enjoying it? Please do let me know in the comment section below. If you do have any feedbacks or suggestions to improve this channel, or if you want me to discuss on any particular topic or problem, then you may also comment that in the comment section below, or you may WhatsApp me directly in my WhatsApp number, which is given in the description box below. So let's start today's session. In today's session, we are going to discuss about a problem on mechanics, which is a typical and interesting one, which deals with the rotational and translational equilibrium of a body on an inclined plane. So what the problem states is, there is a heavy block of length b and height h, which is placed at rest on a rough inclined plane of inclination theta with the horizontal. The first part says the normal reaction from the surface cannot pass through the center of mass y, and the second part says if mu is the coefficient of friction between the block and the inclined plane, then discuss the conditions of translational and rotational equilibrium of the block. So let's start with the first part, which says why the normal reaction force cannot pass through the center of mass. So if we draw the free body diagram of the block, so this is our incline, which is at an angle theta with the horizontal, and this is our block here, heavy block, and its center of mass is here. So we all know weight of the block mg is acting downwards, and we can easily resolve the weight into two components. If this angle is theta, you can easily derive from simple geometry that this angle is also theta. So this component which is perpendicular to the plane is mg cos theta, and this is along the plane mg sin theta. But all these components are acting through the center of mass. But since the inclined plane is not smooth, it's a rough plane, so there will be a frictional force F, which is acting up the plane if the body tends to move downwards. Okay, so in normal case, what we can see is this mg sin theta, mg or mg cos theta, these three forces cannot produce a torque about the center of mass, because these are acting through the center of mass, and the torque produced is the force into the perpendicular distance. So put the perpendicular distance from the point of rotation is 0 here for these three forces. Only the frictional force is at a distance of this, which is given as h by 2 in the question, because the complete entire height is h. So what will this force will do? This will produce an anti-clockwise torque, which will try to topple this block about this point A. So what will happen to this block? The block will try to topple about this point A if there is no other force to balance this torque. So what will be to keep this block in equilibrium, what should we do? The what will balance this one? The normal force. Usually we consider the normal force here, but in this case the normal force cannot act through the center of mass, because then the frictional force will force the block to topple about point A. So the normal force, and when the block starts to topple, then all of the contacts except this point A is gone. Only the contact point with the plane is this point. So the normal force is a contact force, so this normal force will shift here to produce a clockwise torque here, because from normal force to the center of mass, this distance is given as b by 2, because the entire length of the block is b, so this is b by 2. So the normal force cannot act to the center of mass if we want the block to be in equilibrium position, if we consider the block to be in equilibrium position. So this answers the first part. And what is the second part? If mu is the coefficient, so we discuss the conditions of translational and rotational equilibrium of the block. So for this, let's draw it again. So all other forces, if you can see here, mg sine theta, mg cos theta, these all are acting through the center of mass. So here for translational equilibrium, what will we write? We know for translational equilibrium, summation of all forces, vector summation of all forces must be 0 here. So what will have along the plane, will have f upwards and mg sine theta downwards. So f must be equal to mg sine theta, and perpendicular to the plane, n is acting upwards and mg cos theta downwards. So n must be equal to mg cos theta. These two are conditions for translational equilibrium. And if the block is not sliding down, if the block does not slide down, then frictional force must be less or equals to mu into n, because mu into n is, what is the mu into n? This is the limiting or maximum possible static frictional force. This is the maximum limiting static frictional force. Okay, so F must be less than mu n. So what we can write here is, if F is less than mu n, so we can write mg sine theta must be less or equals to mu into mg cos theta. So mg will cancel out. What we'll get here, sine theta by cos theta, tan theta less or equals to mu. So this is our second condition for translational equilibrium. And now move on to the next, rotational equilibrium. For rotational equilibrium, what we know is, for rotational equilibrium, we know vector summation of all the torques must be 0. So what are the forces that produces torque here? Mg cos theta, mg sin theta, mg. These forces are acting from the through the center of mass. So these won't produce a torque about the center of mass. Only the frictional force F and the normal force N is producing torque here. So let's draw the picture here. So this is B. So this N is acting here. So this distance is B by 2, and what is that? Frictional force that is acting at a height H by 2. So this frictional force is producing an anti-clockwise torque, and this one is producing an clockwise torque. So what will happen here is, we can write from torque balance, we can write normal, this is normal force. So N into V by 2 will be equal to F into H by 2. So from here, what we'll get, 2 will cancel out. So we'll get F is equals to B by H into N. And what is N? N is B by H into N is mg cos theta. Now, if the block do not slide down, if the block topples before sliding, means if the block do not slide down, only topple, then what will happen? Again we'll know if less or equals to mu n. We have discussed this earlier, so we can write it here from f. What we know, f is b by h mg cos theta must be less or equals to mu into n is mg cos theta. So mg cos theta will cancel out from each other, because cos theta is not equals to 90 degrees, so cos theta is not equals to 0 and mg is definitely not 0. So mu must be greater or equals to b by h. So this is our next condition for equilibrium. So I hope you all have understood this problem. If you still have any queries or doubt, you can post it in the comment section below, or may directly WhatsApp me in my WhatsApp number. So keep studying. Bye bye.